50% makes you put 0.02. Here comes your curve, here comes your shade, and there comes your z-score, 2.05. So we're most of the way there. We're most of the way there. Because that's not your IQ score. That's a z-score. That's a unitless score. So I'm going to turn this off. I'm going to look over at my curve real quick. And I'm going to add a 2.05 right there, because that's my z-score. What are we going to do next? Now that we know it's 2.05, say that again, nice and loud. Good.
We're going to minus the average.
Keep going, keep going.
Minus the average.
You're looking at this, aren't you?
Uh-huh.
See, Tiffany's looking at this, she's like, I know I need to use this.
I do. But
She does, because here, we had an x, and we were trying to get it to a z. We're going to swap them.
Okay.
So here's, let me give you some algebraic less nightmarish. Let's solve this for x.
No.
This makes it easy. Multiply by that and add mu, and you end up with, find your x value by just doing mu plus z sigma. If you solve that equation for x, it looks like that. I'll give that to you on the board too during an exam, so don't memorize it as well. You can solve both equations for any variable you want. They look awful, yes? Because there's 4 variables in them, but there really aren't 4. There are really only 2. Because you're going to have this one and this one given to you in every problem. I have to tell you things like, what's the average height of an American man plus or minus what? I have to tell you what's the average weight of a 4-door sedan plus or minus what? You'll have those numbers. And then you'll have one of the other 2. Once you have 3 of them, you can find the 4th. That's algebra, yes? Yeah. So over here, it made sense to have z on one side by itself because you had these 3. Over here, it makes sense to have x on this side because you have these 3. And then it's just a matter of running through the formula your values. You know that the average IQ score is 100. And you know your 2.05 standard deviations above if you're in the top 2%. And the standard deviation is 15 points. So now your units are back. There you go. That's where the 15 comes from.
Thank you.
Yep, yep. So 2.05 standard deviation means you have to go up 15 2.05 times. So what's that going to be? I'm going to call that 131. There you go. Go get a 131.
Oh, wow.
Go get a 131 at least. At least. Madeline, reapply. 49 and a half. Tip my hat. There you go. Go reapply.
Wow.
Fair enough?
I think so.
That's a backwards problem. Notice, and I love what Tiffany was doing. She looked over forwards and said, okay, it's this. I got to go this. Perfect.
You said that in algebra.
Exactly. That's mathematics. I mean, it's inversion. Mathematics is about inversion very often. It's about undoing what you've done to get back to a raw data point. It's with Legos. I mean, think about Legos. When you're putting a Lego model together and you forget to put a piece in, you've got to undo what you did in reverse order to get back to that one piece. It's like building anything else. You lock yourself into me and my son were cleaning out under the cabinet the other day, and I had to pull 2x4s out that I had nailed in 10 years ago. And I had nailed them in an order that I had to pull them back out in reverse order. I laid one in, then laid one into it, then laid one into that, then laid one into that. And I'm like, and I would try to grab this one, it didn't work. I'm like, oh, I did this one first. So, you know, mathematics just works like that. Just like life, which is kind of nice. You got that glazed look. Yes, thank you, Madeline. Let's get the hell out of here, walk around a little bit, and come back in and we'll talk about pregnancy. We'll talk about Michael Phelps. Let's talk about pregnancy.